All right. So in this example, as well as the next example, what we're going to do is find the original price. And so Sandy has a 25% discount, a discount coupon for athletic equipment. She buys hockey equipment for a final price of $172.50. What is the original price? So this example is going to be a little different because in the other examples, we've had the original amount, we've been provided with a discount percentage. We were able to calculate what that dollar amount is of the percent, and then we were able to find out what the sale price is. However, in this example, they're actually going to give us the final price instead of the original amount, and they still give us the discount. And we have to find the original price. So let's go ahead and plug in what we know. So we know that there's a 25% discount. So I'm going to put 25% here. And then we also have a final price of $172.50. And then our original price, we do not know. So that's the reason the problem exists. Now, I want to show you something. So let's think about what we've talked about before. When we talk about percentages, we understand that the whole would be 100%. So what we're basically doing is saying, hey, you are start off paying 100%. And then maybe there's a discount. And if there's a discount, we're going to take out whatever that discount is. And in this case, it's 25%. So if we take out 25% of the 100%, then you're left with 75%. So what this represents is this is the whole. This is what we started with. You get no discount at 100%. The 25% here represents the discount. And then the 75% represents what you pay. So you pay 75%. So we can actually look at a discount problem in terms of what am I paying? And so in this case, we're going to pay 75%. So let's look at it this way. Let's say we are going to plug in what we know in regards to our original and the percentage amounts that we have. So we're paying 75%. So we're going to put in our original amount, which is going to be X because we don't know that. We're going to multiply it by the percentage that we are going to pay, which is going to be 75. And then we're going to divide that by 100. Okay. And when we do that, it should come out to our sale price. Okay. So we should have our sale price, which is $172.50. Remember, 75% is what you are going to pay. So this should represent the 75% that you are paying. Okay. So now what you're going to do is remember when you see it like this, we need to isolate the variable. So I see that X is not isolated because it's being multiplied by 75 and then it's also being divided by 100. So how do we isolate it? I want you guys to think about PEMDAS, which we've seen before. We know that this is our order of operation. So when you are solving a problem, you start from the parentheses and work your way down to addition and subtraction. Okay. So this is when you are solving a problem. Now, if you are trying to isolate a variable, then you actually want to go the opposite way. Okay. So this is when you want to isolate a variable. So you work backwards. So I'll show you what that looks like. So we will start with subtraction and addition. We don't see that, but I do see division and multiplication. So what I'm first going to start off with is getting rid of this fraction. So I'm going to, instead of dividing by 100, I'm going to multiply by 100 on both sides. When I do that, I can cross out the 100 because they cancel each other out. And now I'm left with x times 75. And remember, anytime that we see a variable, we always want to write the coefficient first and then your variable. So we have 75 times x, and that is going to be equal to $172.50 times 100. Okay. And remember, in our previous videos, we know how to move our decimals, so we don't have to go and necessarily calculate it. I know that if I'm multiplying by 100, I just need to move my decimal 2 places to the right. So that would be the same thing as 17250. And you can go and plug that into the calculator if you needed to double check. So we have 75x is going to be equal to 17,250. And then I see here that X is still not isolated. It has that 75 next to it. When we see a number next to a variable, we understand that that's multiplication. So to undo the multiplication, I am going to use its inverse operation, which is division on both sides. And so we have 75 divided by 75. Again, they will cancel each other out. And now X is all by itself. Okay. So we have 175, I'm sorry, 172 50. Let's see what we get. So we got 17250, and we're going to divide that by 75, and we are left with 230. So what this tells me is X is equal to 230. Okay. So the original price was 230. Just to recap what we did, instead of us trying to find the discount amount because the discount has already been applied and this is the amount that we paid, we looked at the problem in terms of our original amount, we subtracted out our discount, and we went to find out how much did we need to pay, which represented the $172.50.